Okay, so in today's lab, we're going to mix warm and cold water. And the purpose of this lab is to see if different volumes, 30, 40, or 50 grams of water, will influence the amount of thermal energy transferred between the two different temperatures of water. So I have a high-resolution thermometer, I have my graduated cylinder, I have a test tube being supported with a beaker, and a calorimeter, which is basically just a styrofoam cup. What we're going to do first is we're going to get our volume of water. For this group, we're going to use only 40 grams of water, and there's going to be different groups throughout the class that are going to use the different volumes, and we're going to compare it at the conclusion of the lab. So for this group, we're going to use 40 grams, and here we go. Okay, so I got my water. We can see by reading the meniscus, we're at 40 grams or 40 milliliters because the density of water is 1 gram for 1 cubic centimeter. What we're going to do is we're going to take our water and we're going to pour it in our test tube. Next up, what we're going to do is we're now going to go over to the hot water bath. The temperature of the water in the hot water bath is between 30 and 35 degrees. Kind of see that? Now what we're going to do is we're going to get equal volume. So again, we're going to get 40 grams of hot water. Now we're going to take our 40 grams, you can see it, of hot water, and we're going to pour it in the calorimeter. And we're going to close it. So the calorimeter is using it as an insulation to keep our warm water warm, and our cold water you can see is just in the test tube because it's only room temperature. Okay, so you can see the thermometer and the calorimeter, the warm water is now increased. The reading is about 33.5, so we're going to go ahead and just record 33.5. We can see on our data table our cold water started at 21.5 and the warm water is 33.5. So what we're going to do now, according to the procedure, make sure that you answered your BDQs before this point. We measured both samples before we mixed them, and as soon as we recorded our temperature, we're going to pour the cooler sample into the calorimeter and quickly replace the lid. So that's what we're going to do right now. Okay, so we can see that the temperature is dropping, so we want to just keep recording our data until the temperature remains at the same temperature for several seconds. We can see it's still changing. Okay, so it's been going for about a minute or two, so we're going to go ahead and call it. We're going to say that the temperature with the mixed liquids is about 28.5. We're going to go ahead and record that on our data sheet. So the final temperature of mixed is 28.5 degrees Celsius. Make sure that you go to the blog to see class data, because you should not be doing any of the BDQs number 9 through 13 until the class data is listed on the board. If you're absent, it'll be posted on the blog underneath the video. Have a good day.